To keep it very simple, Internet of Things is smart connected things or smart connected devices. So if you have any, say, phone or this laptop or this chair you're sitting, if it is smart and it is connected through cloud and can communicate to the human being or any other device or any other thing, that framework is called Internet of Things. And so the concept is, it is expected that by 2020 about 50 billion devices will be connected and this market will be $11 trillion. So a lot of people say that we are actually entering into what is called as the Industry 4.0, Industrial Fourth Revolution. And everything, the way we live, everything will change in coming years. As a default, most of the company will end up having all products and devices which will be there in the market, which will be connected, be it refrigerators, be it the cars. Cars are already autonomous. We're talking about that's an example of Internet of Things. And you name it, like your lighting system, everything will have sensors and will be connected. So first, let's talk about what are the industry which will get impacted or which will leverage it. People talk about smart homes, so that is one thing. The second is smart cities, wearable devices. You're talking about healthcare, IOT in healthcare, IOT in energy efficiency, like a lot of grids and greenhouse effect, and saving millions and millions and billions dollars of energy. And one of the biggest area which will have an impact and benefit of this will be healthcare. So we can talk about some various case examples and a lot of movies it is already shown. In the manufacturing industry where I belong, like I work with all product design and manufacturing company, this Internet of Things concept is called Industry 4.0 or Industrial Internet, IIoT, Industrial Internet of Things. So there we already have many case examples. The classic case example, which is now a very, very hot topic of discussion, is autonomous car. Mm-hmm. So you may have already seen Google and Tesla's and all the big car companies already have their autonomous car already ready. Just take an example. One of the product division, G has multiple products from healthcare to lighting to energy to all. They also make one of their biggest division is aviation, where they make jet engines. So suppose for any movement, say I'm just giving an example, 2,500 jet engines of G are flying around the world in the commercial aircraft. So the flying condition of an engine in Alaska or a very cold belt will be totally different than say Middle East or Saudi Arabia, and the wear and tear, and maybe an engine is just doing a small city hops, or one engine is doing transatlantic journey. The wear and tear of that engine will be totally different. They are trying to optimize their asset, like how much far I can run this engine, or they are also trying to take an advantage of avoiding downtime, because the most expensive thing for an aircraft is engine failure or engine is down. If engine is down, the aircraft is not flying. If the aircraft is not flying, you're losing millions of money, both the commercial aircraft or because there is a tie-up with all these engine manufacturers. So even the GE and Rolls-Royce will be losing, and Pratt & Whitney will be losing money. So all these engines have a lot of sensor, and they continuously keep giving data on a digital model, which is called digital twin. And this concept, as Internet of Things will become more popular and pervasive, digital twin will become very, very common. Every product in the market which is worthwhile and valuable will have a digital twin or exact replica. So as the engine is behaving real time, the digital model or digital twin will be continuously showing what's happening to that engine, and one can take kind of corrective action. We are saying that by 2025 it'll be $11 trillion market, Internet of Things. and you can imagine and do the mathematics. Even if we take about 15-20% of that market potential as a service provider, because India has got tremendous potential and very smart people. A lot of our smart IT software companies are focusing a lot on IoT opportunities. So healthcare can be immediately implemented.
Smart. They have the infrastructure there?
Yeah, meaning it is up to the end consumer and the doctors and hospitals, correct? So if there is an elderly person in India, say in Pune, a retired elderly person, and their kids are in America or wherever, and they need not have necessarily all the time attendant all the time. Then the IoT, the smart home, and the smart clothes or sensors or nano robots which their body will have will continuously keep giving information to their doctors what is the condition of the patient. With India as one of the fastest developing nation, power is very important. And how do we optimize the power resources and power grids across India? And if imagine all these power grids are connected to IoT, and all the power grids are smart, having all the sensors and all, can be a huge advantage. But going into smart cities, which is again an application of IoT, will take a lot of time,
and a lot of initiative from the government.
Government is required. Yeah. Now, mechanical engineer will also create a smart IoT device, correct? Suppose the automotive engineer or mechanical engineer is working for a car company, then the car company will need first a mechanical engineer, a domain expert, then his additional skills, which he as a part of his curriculum or as a on-job training or as a part of his company learning, will also learn how to put the sensors and make my car IoT enabled. You need a lot of data analytics guy, a lot of AI guys, a lot of machine learning guys, deep learning guys, a lot of coding guys who will be developing all these technologies. Yeah? On the back end for our infrastructure, IT's computer science engineering stream will naturally help him. Yeah? We have more than 750 PhDs in our company. We have a lot of PhDs in India also, and most of the people we have in our software development and technical support are at least minimum BTech or MTech.
Which you take from the local colleges?
Yeah, mostly from reputed colleges.
Reputed tier 1?
Yeah, tier 1 IITs and the top engineering colleges. India is becoming like a back-end services value-added capital. We may not be a manufacturing capital like China, but from the intellectual and IT and software and engineering and simulation perspective and design perspective and niche application, we are very good. So we are becoming the back-end capital. As we speak now, not many people know that apart from IT and software, India is already the design and simulation capital. So the company and the field which is called simulation, India is already, so all the big companies like GE and Cummins and Honeywells and Bosch, they have their biggest design and simulation centers in India. Like GE has a Jack Welch Center in Bangalore where 5,000 engineers are day in, day out designing global products out of India. What we are trying to, and I'm encouraging the industries, why don't we go back to academia and invest and kind of skill the academia with latest technology. And I meet every day a lot of academia and universities and college which are ready. They know that their curriculum and syllabus is obsolete and their students are not employable because there is a big gap between what industry needs and the skill gap, the students which are coming out. And we are talking about that no, there is unemployment. No, there is no unemployment. There is, if you ask ANSYS or my other peers in my industry, they need people but good people, trained manpower is not available. So there is a gap. How do we bridge that gap? So I think either they should be sandwich courses, or we are changing the curriculum and syllabus. And now when these students come out, not necessarily they can join Cummins, but they can join any industry. And I'm part of off-highway, SAE off-highway board, and all these off-highway companies, automotive companies, are ready to hire these students. So I started with a boutique store in Kalagoda in Mumbai, and I was selling 286 and printers, and that time it was considered as rocket science, 286, a CAD software, engineering software, CAD design software. And that's how, and then I joined one of the biggest CAD design company called Parametric Technology. I was there for almost 17 years, and I kind of started my journey over there from a basic sales guy, and went up to various level and ended up becoming the country head. And for last 3.5 years, I'm at ANSYS. I'm a very, very organized guy. I do a lot of planning. I do a lot of forward thinking. I have a written down goal for my life, which I know what I want to achieve. Every day, every week, every year, I know what I'm doing and what I want to achieve in my life, not only professionally, personally, spiritually, or as a human being. As I started learning their language. You are not an advisor, trusted advisor, then the customer will not. Nobody has time. Nobody wants to talk to some sales guy from an IT company or a software company, because everybody's busy. We can, where US and Europe and Japan try to follow process, we'll do exactly or follow all the process and do the job of implementing the process. The infrastructure goes haywire, there's a water logging. You're stuck, correct? Because India is not just big cities like Pune, Bombay, Chennai, Delhi, but India is a growing city with a lot of tier 2, tier 3 cities. How do you reach out to all this? Because there are a lot of small scale industries in tier 2, 3 cities, a lot of startup companies, a lot of bright people. How do I reach out to those people? So I think that is also very important. Very smart. They have a lot of fresh ideas. They are connected with what is happening. What I also kind of coach and tell them, which is an area of improvement, I don't say it's a negative, because the area of improvement is patience and looking at the long-term solution, because we cannot be a short-term thing, and you want to quickly, every few months, I want a raise, I want to now want a next very exciting project, and I'm getting bored of this. So I think we should know how to harness their energy. Some of these young guys, I call them unguided missiles. And the key as leaders and managers is how do you guide them? And if you guide them, then they can be some of your brightest stars.